This is free response question 2 from the 2024 AP Calc BC exam. It is part of the graphing calculator section. A particle moving along a curve in the xy plane has position x of t, y of t at time t seconds, where x of t and y of t are measured in centimeters. It is known that x prime of t is this and y prime of t is this. At time t equals 2 seconds, the particle is at the point 36. Part A says find the speed of the particle at time t equals 2 seconds and show the setup for your calculations. To find the speed of the particle, we're going to have to calculate the magnitude of the velocity vector. The velocity vector is just made up of x prime and y prime, as its x and y components, so to speak. And then we just have to square those, add them together, and take a square root. That's the magnitude, which is the speed. So here for part A, we are looking for the speed of the particle at time t equals 2, and we know that this is the magnitude of the velocity at time t equals 2. The magnitude of the velocity is going to be the square root of x prime of 2 squared plus y prime of 2 squared. And let's consult the graphing calculator for this. I'll just do the inside of the square root first, and then we'll take the square root of the result. X prime of 2, that's pretty easy to evaluate. That would be 8 times 2, which is 16, minus 4. So that's 12. But then we have to square it, which is 144. So x prime of 2 squared is 144, and then we will have to add y prime of 2 squared. So we'll plug that in. Y prime of 2 is going to be negative 2 plus the square root, we're looking here, the square root of 2 to the power of 1.2 plus 20. And this whole thing needs to be squared because that's y prime of 2. So the inside of this square root is about 151.409. Then we'll just go ahead and take the square root of that to get the speed. So that's 12.305. And the units we know are centimeters per second. So 12.305 centimeters per second. All right, on to part B. Find the total distance traveled by the particle over the time interval from 0 to 2, and show the setup for your calculations. To find the total distance traveled, we don't want to integrate velocity because that would give us displacement. Instead, we want to integrate the speed. So for part B, we will be integrating over that relevant interval from 0 to 2. And what we're integrating is the speed. If we accumulate the speed at all the moments during this interval, we will get the total distance traveled. So we're integrating the square root of x prime of t squared plus y prime of t squared. And we will use our calculator for this. So on the calculator, I'll press the math button and then go to option 9 for the integration function. And then very carefully, I will type this whole thing in. All right, I've typed the integral into the calculator. We're using x in the calculator rather than t because that's more convenient. And we get 15.902. And again, this is in centimeters. So the answer is 15.902 centimeters. That is the distance traveled by the particle from 0 to 2. Now on to part C. Find the y-coordinate of the position of the particle at the time t equals 0, and show the setup for your calculation. So for part C, we know the position of the particle at time t equals 2. We know that it's at the point 36. So we'll start there with that position at t equals 2, and then we'll use an integral of the velocity in order to get our way back to t equals 0. And remember, this question is about the y-coordinate. So we're going to start with the known y-coordinate, which was y of 2. At t equals 2, we know the position. And then we will accumulate with an integral of the velocity from 2 backwards to 0. And what we're integrating is y prime of t, because we're only interested in the y-coordinate of the particle's position. So adding up all the rates of change of the y position will just get us back to t equals 0 when we add that to y of 2. Y of 2, of course, we know is 6. That was given to us, so this will be 6 plus this integral, and we can consult the calculator for that. Plugging this integral into the calculator, we get negative 7.174. So 6 plus negative 7.174. And 6 plus negative 7.174 is negative 1.174. So that's the approximate y coordinate of the particle at time t equals 0. Finally, part D. For t between 2 and 8, the particle remains in the first quadrant. Find all times t in the interval from 2 to 8 when the particle is moving toward the x-axis, and give a reason for your answer. If the particle is in the first quadrant, then for it to be moving towards the x-axis, its change in y-coordinate must be negative. It must be moving down to approach the x-axis. So we just have to figure out when y prime is negative, and we can do that easily with a graphing calculator. So here in the graphing calculator, I've plugged in y prime. Let's go ahead and take a look at the graph. Have to zoom out to get a good view of it. And there it is. So we're looking between 2 and 8. That's the relevant interval for this part of the question. When is y prime negative? Well, it is positive at the beginning, but then it passes 0 at x equals 5.222. Or, for our purposes, that independent variable really is t. So at time t equals 5.222, that's when it starts to become negative, and we can see that it remains negative certainly past the endpoint of the interval at t equals 8. Thus, the interval of all times when the particle is moving toward the x-axis between 2 and 8 is here, starting at 5.222 because that's when the derivative of y switches from positive to negative, and then all the way up through 8, it's negative that entire time. And since the rate of change in the y position is negative, the particle is moving downwards and hence approaching the x-axis. So since the particle's in the first quadrant, it's moving toward the x-axis when y prime's negative, which we saw from the graphing calculator was on that interval. And that completes our solution to free response question 2 from the 2024 AP Calc BC exam. Let me know in the comments if you have any questions, and be sure to check out my Calculus 1 course and Calculus 1 exercises playlists in the description for more. If you're looking for a bit more practice, check out my 10 hours of AP Calc AB BC FRQs video, linked in the description as well. Thanks for watching.
I'm the mathematical menace, the machinations of mankind. Two calculators at the same time, hand signs and abacus, finger count and calculus. I'm a V to the T, my parameter the rapidest. Happens like this, my lecture's the most prominent, dominant. Call me to Morgan, I get the compliments. The union in together like any time that we intersect, cause my opponents know they need